Okay, physics. So this is sort of a problem that comes up and causes some confusion pretty regularly. So let me go over how to think about these and what helps me to get through these problems. So an example problem is where I have a boat that's crossing a water. So I have the boat moving in one direction and the water moving in another direction. And if I just let this go, what you're going to see is that the boat is going to move diagonally through the water, and so I end up tracing a longer path through this. Let me diagram this and talk you through some of the confusing things about this, and help you understand what to do when you come across these sorts of things. So, the biggest challenge is well, we're using vectors, but we can define a vector to represent any entity that we want, so any quantity that we want. So I can have a vector that represents displacement, so this might be 10 meters, or I could have a vector that represents velocity, this might be 10 meters per second. So a lot of the confusion comes from these this sort of river crossing diagrams that you can diagram that the boat is traveling this far, so it's going to travel that much distance, and then it travels this much distance down, and the total distance that is traveled has been that much. And notice that on this diagram, I'm drawing displacement or distance traveled, so it makes a lot of sense. Oftentimes, though, we're interested not in the displacement, but the velocity. So in this case, right, I'm going to have velocity of I'm going to have velocity of. So here's my river, and I can represent the velocity of the river is going in this direction, and the velocity of the boat's going in this direction. And I can add those together and come up with a net velocity, but notice I'm representing velocity here, so this distance across here doesn't really mean anything in that context. Whereas here I'm representing displacement. So one of the common things that people want to do is they want to figure out, well, if I want to go straight across the river, what do I need to do? So first, don't think about displacement, think about velocities. Right, so here's my river, I want to go across it. If the current's moving in that direction with that much magnitude, I don't know, we'll call this 3 meters per second, and you want to go straight across the river, well, you know, conceptually you're going to have to angle up. And what does this mean? This means that your angle that you go at, right, that you want to have as much velocity going upriver to counteract all of that flow from the river that's coming downriver. Right? So these two, the magnitude of these two is going to be equal. So if you're going at 5 meters per second and the river's moving at 3 meters per second, right, now I have a triangle problem to solve, and I can figure out what angle I want to head off at. So for instance, I know this leg that I know is opposite, so I'm going to use the sine function. So the sine of the angle I'm interested in is going to be my opposite over my hypotenuse. So I'm going to get my angle by taking the arc sine of 3/5. And when I do this calculator, what do I come up with? Like 37 degrees. So if I'm here, if I aim at an angle of 37 degrees here, that the amount that my velocity vector going into the current will counteract all of the current itself, and so I should end up getting straight across. Well, let's see if that works, right? So, so here I'm going to reset this. Yep, it's up to 5. Velocity of the boat is 5. Velocity of the river is 3. So I'm going to put in here 37. Let's see what we get. 37. Okay, what's wrong with that? So think about this for just a minute. So the directions matter. So we have velocity of the river as being positive and 3. So positives go in that direction. And I have velocity of the boat in the y direction, so I'm making positive upwards for the boat. They give me some here. So to make this work, I want to send the boat in the negative direction, right? So it's got to be going the opposite direction of the river. So I'm making negative 37 degrees in this case. So then my velocity of the boat's going against the velocity of the river. And I'm hoping this is going to go right across the river. There it goes. Whew, made it. Okay, so a couple things to worry about here. So there it is. Again, Key thing is, if you have a river, be careful what your vector is representing. Either it's representing displacement, or it's representing velocity, or it's representing acceleration, or later we'll get into other stuff like momentum. But you can't combine those two together, so it can only represent one quantity, so you got to decide what it is and then stick with it. And then be careful in velocity. A lot of times you want to counteract something. That in that case, you're going to have a leg of your triangle, which is going to be known. And that should make sense. Hopefully it helps. I'll talk to you soon. Bye.